Good morning. Today is Wednesday, March 25th. I want to give a quick shout out. We haven't done this. I forgot to do it yesterday to some of our friends in my class. I think Miss Fofo will be doing her shout outs because I only have our 6 today. And I remember I did 3 of them the other day. When I moved all my stuff to home, I just put all the names back in the jar. So if you hear your name again, sorry about that. We'll get to everybody, I promise. So I'd like to give a shout out to Caden M. Hi, Caden. Hey. And Logan. Hi, Logan. And I'd also like to give a shout out to Sydney. All right, so let's get started with our math lesson today. Today, you're going to need your math books, your whiteboard marker, pencil, all the things that we typically use. Also, grab your fraction tiles as well. If you need to get them, pause the video and then come on back. Excuse me. All right, let's go over the, open to page 275, please. You're working on 275. We're in lesson 3, fractions. We're going to be talking about explaining fraction equivalence using visual models. So our I can statement says, I can use a visual model to show that 2 fractions are equivalent and then explain why they are equivalent. So let's look at the problem they have us working on today, the Spark Your Learning. It says, compare Jason's and Kim's turns. Whose turn is closer to being a full turn? Use the visual model of each turn to explain. So in your book, it actually has these little fraction pies in your book. So let's take a peek again. Let's find out what is the situation about. So we're talking about some kids turning on their skateboards. So let's go back in now and try to find those quantities of the situation. So let's take a peek again. It says, compare Jason's and Kim's turns. Whose turn is closer to being a full turn? Use the visual model of each turn to explain. Well, so now let's go down below. So I have my hole, which is the same size as both of Kim's and Jason's turns. So they're both being measured with the same hole. But Jason, he's measuring his turns in fourths. And we can tell that if you're looking at that chart, the pie chart on his visual, is that he has his broken into 4s. But he only turns, well, I'll take the one away that he did, 3 of those 4. And so we can represent this as 3 over 4. So the whole is broken into 4s, 1, 2, 3, and then that 4. But only 3 are shaded in. And in his case, that means he's only turned 3 out of the 4 pieces or parts. So let's go back and find out where Kim is. So hers is broken into 8s. And so she only turned 1, 2, 3, 4, 5, 6 out of the 8 total. Okay. What would be a question that we could ask here? So let's go back to the question. It's saying to use whose turn is closer to being a full turn. So whose is closest to going completely all the way around? Well, if you look at the 2 visual models that we have in front of us, and I were to turn them so that they're facing the same way, I'm going to scooch this one down. I might even go as far as placing them right on top of each other. And you notice they're exactly the same. Even though the hole is broken into different parts, it doesn't mean that they're going to be at different amounts. They can both be the same. And in this case, we know that 3/4 is equal to 6/8. So did one turn more than the other? No. Whose turn is closer to being a full turn? Well, they're both equal. I want you to notice something before I shut this video off and go on to the next Build Your Understanding. I want you to take a peek at your denominators. These are even numbers. Okay? And we're going to use that information in the next video. So take a pause and tune into your next video.